Good morning, everyone, and welcome to my presentation on CI/CD with PowerBuilder using Azure DevOps. My name is Curtis Hanner, and I'll be your presenter today. On the agenda, we're first going to talk about the classic, traditional way you automate your PowerBuilder builds. Just kind of like where we're starting from, what our baseline is, and maybe identify some of the challenges with that approach. And then we're going to talk about Azure DevOps, just give you a quick overview of what it can do for you. And then we're going to dive into the source control for Azure DevOps, which is called repos. And we're going to show you how to set that up in Azure DevOps and then show you how to integrate that with PowerBuilder. And then we're going to dig into Azure DevOps pipelines and show how to automate your build and automate your deployment. And one challenge that I encountered setting this up is, well, I think the main problem was that I wasn't able to do a silent install of autocompile, and we'll get into that later. So the workaround for that is to set up an Azure Vm, which I use as my build agent. And we'll get into that in detail in that section. A little about me. My name is Curtis Hanner. I'm a software engineer with the City of Seattle. I've been working with PowerBuilder for over 20 years. And before joining the City of Seattle, I was an independent consultant working in the insurance and banking, brokerage areas. As you can see from some of my past projects that were more brokerage finance related. And now at the City of Seattle, I'm working to support an in-house client-server PowerBuilder licensing applications that's used by about 200 people at the city. We recently upgraded that to PowerBuilder 2019, and we're in the process of upgrading to Windows 10. And we also upgraded the database client to the SQL native client, which went pretty smooth. And then we also upgraded to 64-bit in this latest release. A little about the City of Seattle. The City of Seattle has about 14,000 employees, and part of that is because we are the water utility and the electric utility for the City of Seattle, and running all those, we have 4 major dams, and just running all that infrastructure requires a lot of personnel. Our IT department has about 700 people, and out of those, we have about 200 in our applications development group, and we manage over 1,500 applications, custom applications for the City of Seattle. Here's a little picture of the City of Seattle. If you want to win the door prize, you can tell me, if you can tell me where this is taken from. Like, obviously this is taken from, well, maybe it's not obvious, but this is taken from a drone. And the drone is flying over, or I guess it could be an airplane, but it's taken over what Seattle neighborhood? If you can answer that, you'll win the prize. So why CI/CD? Well, I should start by saying CI/CD stands for continuous integration, continuous deployment. And the main reason is to reduce risk. And you reduce risk by every time you make a change to source control, to your code, that you're doing another build. So you build from source control, which can involve a lot of problems with regression defects and forgetting to check something in. And it also helps you identify issues early. So if there's something breaking the build, you find out about it right away. And often that makes it a lot easier to resolve the issue. Um, you also can build faster. Maybe not faster so much, but the thing is, you can. It's just like you don't even really. Previously, you'd probably have to build on your dev machine, and now, and it might tie you up for 30 minutes, an hour, or whatever, to do the build. Now it seamlessly kicks off, runs in the background, and hopefully it's more reliable because you have less manual steps involved. So this is the active learning section or element at this point. So my question I have for you is, how much time do you spend doing builds and deployments? How about you? How about you, sir? How much time, if you have to do a build, how long does it take? And how about you? How long does it take? And if that was less painful, if you could do it easier, more efficiently, more reliably, perhaps you could iterate more in the cycle of deploying, say having changes, coding the changes, deploying them, testing them, and moving them to production. And if you could reduce the time that you do that cycle, I think it gives everyone a better experience. The customers, the analysts, the developers. It's just better for everybody to iterate more quickly over the changes to your code. So now we're going to talk about the classic automated PowerBuilder build process. Or you could do a lot of these steps manually as well. So this is the way I do it. So I imagine other people do it differently, but I think this is pretty standard. So I have a script that does the build, and in the past I've used PowerGen, or there's other ways to do it, but currently I'm using PBC 190, which is the PowerBuilder standalone compiler that doesn't require a license, that just comes free with PowerBuilder. It's part of autocompile. And then I have a deploy script, which takes the EXEs and PBDs that were just generated by the build and moves them along with any necessary DLLs and other objects that need to be delivered to the user into a separate folder. And then I have another script. Now this probably differs from a lot of people, but at this point you could simply deploy all the objects that you did in the previous step. But the way that we're forced to do things at the city is I need to create an MSI to install this on the couple hundred users using this product. So I have a script that uses install shield that does the build, and then I have another script that deploys the MSI. So we're just going to walk through that process. So to build the script to do the PowerBuilder compile using PBC 190, you can simply open your project object, and you can, down here at the bottom, here I'll zoom in on this part at the bottom here. At the bottom here, it has the PBC runtime parameters, and you simply, the script is simply PBC 190 and all these parameters here. A couple problems with this is that, well, there's a lot of hard-coded stuff in here, like directories and version numbers, and anytime you change that project object, you're going to have to change the script. And actually, this DevOps solution doesn't really help with that problem, but that's just a known problem there. And then I have this deploy script, which simply takes the source, which is where my exe and PBDs are, and the runtime, and it just copies those files to the location where I'm going to build my MSI. Basically, this is just copying the files that are going to be used for the deployment. It also copies, in my case, I copy these TTF files, which, well, actually, there's just one file, and it's a barcode true type font that we need in the application. And then the next script that I use, this is the one that calls the Orca, not that Orca, what am I saying? This is this script runs the install shield compile. So this this basically uses all the settings in this file called PowerBuilder ISM, which has it defines all the files, and it defines all the DLLs, and it defines all the registry entries that are going to be used as part of my build. Basically everything we just copied in the previous step, plus the registry changes, and it builds the MSI. And then this final script deploys the MSI, so it copies it from wherever install shield puts it. And I really like this part here, and I call it one of my golden nuggets of information, where it copies the file and then adds on the date and time, the current date and time. And I think this is really useful instead of you having to have a manual human process to rename these MSI files, so you don't get confused on what the correct version is that you're working with. So that covers the classic build process. Now we're going to look, we're going to do kind of an overview of Azure DevOps as our next topic here. So some of the benefits of Azure DevOps. I mean, I'm really not trying to make a compelling case here for using Azure DevOps, but some of the benefits are that it helps you deliver on a 4 eyes principle. So you might have auditors or regulatory agencies or management that wants you to have a second person, so 4 sets of eyes, look at something before it happens. So that might be, and Azure DevOps lets you control that in a reliable and secure way. So for example, you could say you could say that you can set up a rule that says if someone's making a change to source control, they can't simply just push it to the master branch. They have to do what's called a pull request. And that pull request then needs to be reviewed by a different person with the authority to promote it to the master, and then they approve your change and promote it, or they send it back to you and say, oh, no, you need to fix some other things before we approve your pull request. Similar to that, you could have a second set of eyes that need to look when you request. You could have a rule that says if you're going to do a build, you need to have a second set of eyes look at that. You could also say if you're going to do a deployment to certain environments, that you have to have a second set of eyes look at that. Like maybe it just automatically builds and goes to dev, but then if you want to go to UAT or prod, then you need to have a second set of eyes review your build before it goes. And the nice thing about all these changes, I mean, this is actually kind of a new functionality. They say it's in public preview right now, but basically all this stuff is auditable and traceable, and it's not something that you need to, for example, if you're getting audited, you don't have to, it's not really so much your job to prove the auditing strength of Azure DevOps. You can refer them to Microsoft and Microsoft documentation on why the auditing and logging of auditable events at Microsoft in Azure DevOps is strong. This helps you answer questions of who, what, when, and where questions. So if something nefarious happens, you'll know who did it, what they did, when they did it, and what machine they were using to make those changes. Like I said, this is currently in public preview, so it should be available as standard functionality soon. Another benefit of using Azure DevOps is that in a lot of larger organizations, they have a site license for Azure DevOps, and all the other developers say they're doing C# or Java or whatever, they may be using Azure DevOps. And the tips and tricks and tools and methods I'll show you here lets you as a PowerBuilder developer join in on the fun. and it also kind of makes your efforts more legitimate, because you too are using Azure DevOps. And another benefit that I didn't really mention here on this slide is that it gives you a lot of visibility and transparency into what you're doing. So people, you can allow, you can, I mean, you don't have to allow, but you can allow people to look at your source code changes. They can look at all your commits. They can see, look at your deployments. They can, and perhaps all that stuff will be linked to stories, and they can get some insight into what's going on, which is very powerful and could be a great benefit in your enterprise. For the auditable and traceable stuff, this is a screen of that I just captured from some documentation at Microsoft. And for example here, so this is under Azure DevOps. There's an auditing tab now, and for example, you can see here that this person accessed the audit log, and then this person, whatever security changes were made, this person was given permission to allow audit log access, and this person down here, it says somebody created the foobar project, and this says 3 permissions were set. I mean, it just keeps track of all that stuff, so you can, if there was something nefarious going on, you could see what that was. Now we're going to go a quick overview of Azure DevOps. So Azure DevOps is a bunch of different sets of functionality that is all tied together in one system called Azure DevOps. So one of those areas is boards, and this is follows the Agile Scrum framework of doing software development. So you have stories, and it supports storyboards, and they have Scrum storyboards and Kanban storyboards, and you can point your stories, and it supports having a backlog, that you can have a backlog owner that maintains a list of stories that you're going to be working on soon, and it just supports that whole process. Repos is the source control portion of Azure DevOps, and it supports Git or TFVC. Pipelines is the tool for automating your builds and automating your deployments. Test plans obviously lets you define your tests and execute your tests. And artifacts is a way to store packages. I don't see how this really applies to PowerBuilder, but a lot of software development nowadays involves importing and utilizing a lot of different packages from Maven or NuGet or whatever, and it lets you host and share and control those packages. Also gives you alerts of security concerns about packages that you might want to revert to a previous version of something because the latest version has a vulnerability in it. So this is the main Azure DevOps screen. I created this new project called Fresh Demo, and you can see here up at the top it has the project, Fresh Demo, and then down here we have boards, where you could see all your stories that you're working on. Repos is source control, pipelines, test plans, and artifacts, like we just talked about. This is the Kanban. This is actually real data that I'm working on, so don't look at it too closely. This is a Kanban board, and for our you can customize the swim lanes. So they call these columns swim lanes, and you can just drag the stories between the swim lanes as you work on them. So we have the far left is the backlog, and then when they're ready for me to work on something, they drag it into up next, and then I move it to analysis. Well, usually I skip the analysis and just go straight to development. And then when it's in testing, we have UAT, and then sometimes things get blocked because I'm like waiting on a clarification for requirements, or I'm waiting on something from another vendor or whatever. And then when it's completed, I move it to deployed, and just dragging it to deployed closes the story, which I think is pretty nice. So, like I said previously, there's storyboards for sprints or for Kanban. It lets you manage your backlog, so you could have a backlog owner that works in Azure DevOps, managing your stories and setting the priority of your stories. And it really supports all the key functionality you would need for your team to do Agile Scrum. And you can also relate your stories to repo changes, and you can also relate it to your builds and your deployments. So it kind of gives a lot of visibility into what's going on and where it is in the process. Repositories are, well, they just call them repos. This is the source control. So you can use Git, which is a distributed source control system that I'm not really going to get into, but just to say that with Git, everybody using Git has a local copy of the complete repository with the entire history. And then there's also a remote repository, typically on a server someplace, that also has the full copy of source control, and with all the history and all the objects. So the idea is that if you can, if you're disconnected from the server, if you're working remotely, if you're offline, you have full power to do whatever you want. You're not like, oh, well, I can't commit this change until I get back to the office. So you can do it because you have the whole repo right there on your machine. And that Git is a very complicated topic, and I don't really get into a lot of details of it, other than that you have a local repo and you have a remote repo. TFVC is basically the TFS version control that we've used for years. So Git is really what we're going to be using for the rest of this presentation. It's the Microsoft standard. It's the City of Seattle standard. It's really the industry standard at this point. So when we're talking about repos and source control for the rest of the presentation, we're talking about Git. So next we're going to talk about how to configure PowerBuilder to use Azure DevOps Git. There was a requirement that your workspace and your repo name had to be the same, but I don't think that applies anymore. I saw that documented a few places, but I don't think that's the case anymore. But if you run into weird problems, that might be a cause for your problems. So then we're going to talk about creating credentials for your Azure DevOps repo, and that has also changed, but we'll talk about how that's currently looking. And then we will get into adding it to, going into PowerBuilder and adding it to your project, your target, your workspace, to source control. So in Azure DevOps, when you want to go to create a repo, this is what you're going to see. You simply just give it a name, and then you can have a README, which is, well, a README, and then you can also have a get ignore, which supplies a list of files that you want Git to not promote, the objects that you don't want it to promote to source control. So you don't want it to, when you do commits and pushes, you don't want these objects included. So that might be like, I don't know, that might be static elements or third-party DLLs or what have you. So then it creates your repository, and then it presents you with this screen, which sorry, I had to have a sip of coffee there. And I tried to pause this recording, but it didn't work. So I apologize for my slurping. But anyway, so what you want to note here is you want to get the URL here to clone your computer, the HTTPS URL there. You want to just copy that to Notepad or something. And I think that's all we really need for our PowerBuilder. We're not going to use the command line, and we're not going to import a repository from someplace else. And then this is like the same information, but this is under clone. So if you go to the repo and you open it up, well, this obviously has stuff in it already, but even if it was empty, like there was no files here, on the upper right-hand corner here, you see the clone button. You click on that, and then it opens up all this information, and here is the URL again. And then you can put in here a username and password that you want to use for Git, and you can save those credentials there. And then you can use that later in PowerBuilder to give PowerBuilder access to this Git repository. So, you want to save these three elements: the URL, the alias, which is your username, and then the password. So I don't think we have to do this anymore, but like a couple weeks ago at Azure DevOps, the way you would get access to the repos would be to set up these personal access tokens. And you would put in your name here, and you would typically say full access. Anyway, and then it would generate a random password for you. So now we're over to PowerBuilder. If you look under the Workspace, so this target and Workspace, whatever, this is not in source control right now. This is, and if you look under the properties for for the Workspace, and then you go to the source control system, the only option here is to either select none or PB native, which neither of those is what we want. So what you want to do instead is you want to right click on the Workspace, and you'll see an option here to add to source control, and you want to pick that. And then that will take you to another page where you get to pick if you want to use SVN, which I believe would work with TFS, but I haven't really checked that out. And then the other option here is Git. And Git is the choice we want. So you select that, and then it asks you for your name and your email, and this information will be included on all the commits that you make to the repo and source control. So I don't know, my name here is called Elevate Hanner, whatever, and just my email. And you say OK, and now it lets you commit all these. Well, this is my initial commit, so I'm gonna add all this stuff to source control. So what it does is it does a git commit, and what this does is it commits it to the local repository. So now I think I might have skipped a step here, but oh yeah, now if you go and you look under, so now it's just committed to the local. It hasn't been pushed up to Azure DevOps because we just committed it to the local repository. So if you look at the Workspace here, at the properties of the Workspace, under source control, it'll show you here that there's no user ID, no password, no URL, the three things that I told you to write down from Azure DevOps. So how do we get there? Okay, well, the next step we have to do is we have to push. Push is the method that we are using here to move the code to the remote repository. So you right-click on the Workspace. Push is only available at the Workspace level. So you right-click on the Workspace, and you click on Git Push. And then you fill in all this glorious information. So you put in the URL. The Workspace name is already filled in. And then you put in the username and the password. Then I would test the connection here. And assuming that's all good, then you click on OK. and then typically what happens is that it fails. So if you did add like a README, or if you added a get_ignore file, or there was some other change that was pushed to your repo, then you'll get this error. It'll say get client error, reference was not fast forwardable, which is super not very clear. And what you want to do when you get this message is you want to do a pull. So first you want to get synced up with what's in on the master at Azure DevOps. So you right click on the workspace and you click on get pull, and then you get a message like this that says it's pulling down files. And actually I created a YAML file here, which we're going to get to later. And then you can right click on the workspace and do git push again, and then it will successfully push all your stuff up to the remote repository. So now ADO, by the way, ADO just stands for Azure DevOps. So this is kind of the general workflow for in PowerBuilder when we're making changes. So you make a change. There'll be in PowerBuilder there'll be that check mark to indicate, like the green check mark that indicates that it's checked out, but it's not really checked out. It's just been modified. And then you can check it in to, well, you can do a commit to the local repository, and you can do that at the target, or at the workspace, or at the library, or at the file level. And then you can do a push, and then so that you change whatever, some data window in a Pibble, and then you do a git commit on that. And then after you finish, say maybe you change like 4 or 5 objects, and then you want to push to the remote repository, then you have to go to the workspace level to do the push. And so then you would right click on the workspace and do a git push, and then it would push it to the remote repository. So that's kind of the workflow there. So next, that really kind of covers it for the repositories. So now we're moving on to pipelines, and this is kind of an overview of the flow, is how I see it. So you're the developer, you're making changes in PowerBuilder. Your changes get moved up to the master, which is the repo on Azure DevOps. Typically, when you make a change to the repository, it automatically kicks off the build, which is your CI. It builds your exe and your PBDs, and then the next step is to have the pipeline do the CD, which is the delivery, and then that pushes your objects, your exes, your PBDs, and the PowerBuilder runtime to the user. So in my next section, I'm going to get to I'm going to discuss pipelines. Why Azure Pipelines? Well, we've kind of talked about this before, but implementing CI and CD pipelines helps to ensure consistent and quality code that's readily available to users. Azure Pipelines is a quick, easy, and safe way to automate building your projects and making them available to users. Well, that just sounds like stuff straight from the marketing department at Microsoft. Anyway, so we're going to jump in here and we're going to create a pipeline. So I've just selected pipelines, and then I said create, and the first thing that comes up is where's your source code. So in our case, I mean, you can obviously get it from several different places. You could put it on Bitbucket or GitHub or whatever, but we're going to use the Azure repos Git. And then the next step is which repository you're using. I only have one repo in here, so I'm going to pick fresh demo. And then it wants you to configure your pipeline. This is kind of where things went off the rails a little bit for me, because there's no kind of like freestyle, like, I don't know. Okay, so my development environment isn't included. There's no PowerBuilder here, so what do? There's no freestyle. There's no PowerBuilder. So can I leverage one of these? Oh, I don't know. Maybe I could like say it's some Windows build, like a .NET desktop or something, and then I could just have the autocompile install like with a script or something. Because the way this process works normally is that it would pipelines would just spin up a Windows machine, and typically one that's patched with all the current security issues or whatever, and then it would install all the necessary software for you, and then it would get the latest source, and then it would do the build. And you could add in custom steps in there, so you could add in a step you would take out the steps to install Visual Studio and .NET and whatnot, and you could add in a custom step that says install autocompile. And autocompile, by the way, I don't think I defined that previously, but autocompile comes with PowerBuilder, and it installs the Orca Script, which is used to update your source it updates your pibbles with the latest object code from source control, or in this case from Git. And so anyway, autocompile comes with two things. It comes with Orca Script, and then it also comes with the PBC 190, which is the PowerBuilder compiler. And all of that doesn't require a license. You can just install autocompile wherever you want for no charge. So anyway, so then the next step, I just picked .NET Desktop, and then I got this YAML file, and here it says it's triggered from the master. So if someone promotes something to the master, pushes something to the master, then it'll trigger this build, and it's going to use Windows latest. That's the pool VM image. And the other nice thing about this is that it spins up this image file, and it does the whole build process, and then it destroys the VM. And so you don't have to worry about managing, updating, whatever, your own VM. Anyway, and then this is stuff, the rest of this stuff is really particular to a .NET desktop app. So it's doing NuGet stuff, and anyway, this goes on and on. This is just the first few lines of this. So I tried to do a scripted install of autocompile, but it would not work. I spent a lot of time on this, and it was rather complicated. You have to do like a thing where I came to learn that autocompile is using install shield, and then you can run the install with a /r, which gives you an ISS file, which is like a install shield response file or something, and then you can and then you should be able to run it with the right switches, and it should just silently install autocompile. But that doesn't work because autocompile has what they call a custom dialog that I don't know how to script. And when I read about these custom dialogues, they were basically saying, oh, if someone did that, then you should just take him out back and shoot them, because that's a horrible thing to do, because then you can't automate your install. You can't do a silent install. So long story short, I need another solution. So my solution is to create an agent pool that uses a custom, what they call a self-hosted agent. So basically, I'm going to create my own VM. I'm going to put everything I need on there, and then I'm going to add it to what they call an agent pool. And then when I do my build, I will tell it to just call to utilize that PowerBuilder agent pool. So we're going to walk through the steps of doing that. So first of all, I just want to talk about, so that when you normally do it in the more glorious world of Azure DevOps pipelines, you use the Microsoft hosted agents. But because I can't do the unattended install of autocompile, my solution, and I'm sure there's other ways to get around this problem, is to use a self-hosted agent. So this is a blurb from Microsoft. It says, Microsoft hosted agents. If your pipelines are in Azure Pipelines, then you've got a convenient option to run your jobs using a Microsoft hosted agent. With Microsoft hosted agents, maintenance and upgrades are taken care of for you. That sounds really nice. Each time you run a pipeline, you get a fresh virtual machine. The virtual machine is discarded after one use, and that sounds really nice too. Microsoft hosted agents can run jobs directly on the VM or in a container. Okay, well anyway, but unfortunately I can't do that. So I have to go the self-hosted agent route. And so the first step is I need to create an Azure VM. So this is kind of part of this. Anyway, so here's the steps of what's going to happen next. So I need to create a self-hosted agent. So I need to set up an Azure account. And then inside of that, I need to create an Azure VM. And then I need to get RDP working. And then I need to RDP to that new VM, and then I need to install autocompile. And then I have to create a PowerBuilder agent pool. I have to create an agent pool in Azure DevOps. But anyway, I'm just going to call it the PowerBuilder agent pool. And then I register this new build VM that I just created as an agent. And then the build scripts, I need to check those into source control. And then when it gets the latest version of the source from the repo, it'll automatically have the build scripts. So these are the scripts to rebuild the pibbles, the scripts to call the Orca Script, to call the PBC, to build the exe and the PBDs. Well, that's most of what it is. And then create a pipeline to use the new agent and the new scripts. So here we go. We're going to Azure. So here we are. This is the Azure screen as it looks today. I'm sure this is evolving as we go. So basically, you would go down here to virtual machines on the left here, second from the bottom there, just above load balancers. You have virtual machines, and you'd click on that, and then you'd create yourself a virtual machine. So this Visual Studio Professional is the license. I have a Visual Studio Professional MSDN license, and that's how I'm getting. And part of that is I get $50 a month of free Azure usage. So I don't know. There might be other ways to get free access. I think there's a lot of packages available for dev test kind of development that has little or no cost. And if you have an MSDN license, then you can utilize the $50 monthly credit. So I'm going to use SQL Server 2012 R2 Data Center. I'm going to call this machine PowerBuilder. The resource group is PowerBuilder. And I'm going to use a relatively smaller size to keep the cost down I'm using the standard DS1 version 2 with 1 CPU and 3.5 gigs of memory. And then for this new computer, this VM, this is my username, password. And then if you want to do RDP, there are other ways. I don't know. That's RDP is like a whole nother topic, which if I have time, I'm going to discuss that at the end. Maybe other connection options or how to use VPN to, anyway, there's security problems with RDP that have come up in the last few months. And so really, you shouldn't use it just straight out of the box. You should have like some VPN solution. So we'll talk about that later. So anyway, to use RDP though, you need to say, because typically this is just none for public inbound ports. So you want to change that to allow selected ports and select RDP. Oh, well, here we go. We're talking about right now. RDP has been seriously compromised. There was a blue keep vulnerability, I think, in June. So you should really run RDP behind a VPN. So the idea is that you would tunnel from wherever you're coming from to the network that you want to, where the machine is that you want to RDP to, and then you can RDP to an IP that's non-public. My temporary solution with Azure, just for this demo, is to turn on RDP when I want to connect, and then as soon as I'm connected, turn it back off. So you can turn it off after you're connected, and then you can your session will stay connected as long as you're working with it. But you can turn off RDP once you're connected. I hope that makes sense there. Okay. So now we have our new VM and we have RDP, and as you can see, this is kind of how I turn it off. So you select on this and you can change the properties and you can turn it off. Right here it says, this line here, it says priority 300 RDP, and then in the action it says deny. So right now it's turned off. So if I'm going to connect to this machine, I have to turn that on, and then I connect, and then I come back here and turn it off again. Okay, it's kind of a pain in the patooski. But I do say golden nugget. This is another golden nugget of information, is just all this stuff around RDP. So you should treasure that and utilize it. Okay, so now I'm going to, I've added an agent pool here, PowerBuilder. Oh, well, no, I'm adding another one. That's the one that I created previously, but I'm just going to walk through the steps of creating an agent pool. So, bear with me. I think I might have truncated the stuff I was trying to show you here, but anyway, basically you click on this gear down here at the bottom, and then underneath the gear it takes you, that's project settings. So you click on project settings, and then under project settings you go to agent pools, and then you create a new agent pool. And then you give it a name, and I would just check the box that says grant access permission to all pipelines. And then here I am, I have my agent pool, but it has no agents and no jobs and no nothing. So I want to have a new agent, so I click on new agent there. And then it tells me the steps here to set up the new agent. So basically I RDP to the new VM that I created, my build agent, and then I make this directory. Well, basically this is all PowerShell, I should say. First you have to connect, you have to start PowerShell as admin. And then you download this zip file to the machine, and then you run this command here: add type, assembly name, whatever. And then once you get that installed, then you configure it by running that config.cmd. And that's the way you want to do it. The way I recommend doing it, because you can run it interactively, which I don't really haven't dug into that, but I just want to run it as a service, so I configure it as a service to run as a Windows service. So I want to configure the VM as a pool agent. So, okay, well, anyway. So some of the questions that it asks you when I run that configure command there, it wants to know the server URL, and this is going to be, well, in my case, this is dev.azure.com/CurtisHanner. So if you're using an MSDN license, it would probably just be your name. If you have a different subscription, then it would be your organization. And then you need to create a personal access token for your organization. This is just basically a password, or it's a long, looks like a hash. I don't know exactly what it is. And then you enter the agent pool name, which is PowerBuilder. And then you give your agent a name, and voila. Now I have an agent. In this case, my agent is called Fresh Demo 2. Probably should have given it a different name, like Build Agent 2 or whatever. But anyway, that's my build agent, Fresh Demo 2. Okay, so now I have my new self-hosted agent set up. I have autocompile installed, and now I just need to work on my scripts. I need an Orca script, I need a build script, I need to add those to the repo, and then the pipeline is, in this case, is going to be defined by a YAML. Okay, now we're going to work on the Orca script. So in this Orca script, I'm using the -d parameter twice to pass two different variant parameters. One is cur path, and one is the name of the target file, the PowerBuilder target file. So here's the Orca script. Basically, we're not connecting to source control here, because before this Orca script runs, the pipeline is going to get the source from the repo and put it onto my build VM, and then it's going to pass to this file the current path, which is the path that it put the source into. Well, it's going to actually call this Orca script, which is going to be which it got from the repo. I know that's confusing. Anyway, so all this does, basically, all we're doing here is we're telling it, for this target, rebuild the pibbles. That's all we're doing. And it'll rebuild the pibbles with the source that it just got from the repo. I hope that makes sense. So now we're going to create the build. This is going to call PBC, and oh yeah, and this we're calling the PBC 190, which is the PowerBuilder compiler, and the parameters come from the project object in your PowerBuilder application. So this is the build script. So the whole build script is basically just setting up a bunch of variables here. So the name of my target is demo. That's the only value that's hard-coded in here. Everything else is a parameter. So like so yeah, everything's just kind of based on the name. Well, I'm calling it app name, but that's the name of my target, and that's the name of the directory that it's in, and that's the name of the executable and the PBR. And then it calls Orca script, and then you can see here the two -t commands on the Orca script line. That's where it passes those two variables that we just saw in the Orca script, the cur path and the my PBT name. And then that's the name of the Orca script, build-pibbles. and then we build the executable and the PBDs with the PBC 190 command there. Okay, and then this is our YAML script. So this is what the pipeline is executing. So it's saying here that it's triggered when something gets pushed, when a change gets pushed to the repo. That's what trigger -master means. The name of my agent pool is PowerBuilder. And so you can have a whole bunch of agents. I mean, if you're doing lots of builds, or if you want redundancy, you could have a whole bunch of agents under an agent pool. But in our case, we just have one agent in our agent pool. And then there's the target. Then there's just some variables I'm setting up here. The build configuration is just release. It's just a name. And the target is PBT demo. And then this executes a PowerShell command. This PowerShell command is just showing me what the source directory is. And this is where the source was in the step before this. It gets the source code from the repo and it puts it into this directory defined by build.sources directory. And just for fun, I'm writing it out here. And then the next task is a batch script task, and that's where I'm calling the build.cmd that we just looked at. And this build.cmd, it just got it from the repo, and it put it into the sources directory, and then I'm executing it. And then this environment colon down here, that's where I'm defining the variable build_sources directory, which is based on the environment variable $build.sources directory. Okie dokie, that's the whole thing. So then I check in a change, and it gets the source, the latest source code, and then the Orca Script runs and rebuilds the pibbles, and then the build runs and it rebuilds the executable and the PBDs, and there you have it. Okay, now we're going to actually do a real build and deploy in real time. I hope it goes well. Okay, we're going to do a little online demo here. We're going to start by going to PowerBuilder. Let me see if I can get this the right size here. Oh, sorry about this. It's a little big, but not too bad. Okay, there we go. So we're going to start by closing this workspace, and we're going to create a whole new workspace, and then see if we can populate it from the repo. So we're going to start by choose this option under File, Connect to Workspace. So we tell it we want to do Git, and then it already has my fresh demo. I don't know where it's thinking it's going to put this, but let's give this. I want this to be a new workspace. So why don't we call it? I don't know. We'll call it Elevate Demo. Well, let's call it Elevate Demo. And then I'm going to test this connection. That seems to be working just fine. Say OK. Checkout directory cannot be empty. Checkout directory cannot be empty. Oh, checkout directory. Oh, right here. Oh, okay. Silly me. Well, this is where we tell it where we want it to go. So we want it to go someplace brand new. Let's see here. So, well, the workspace is called Elevate Demo. Why don't we just call this new folder Elevate Demo? There we go. Okay. Perfect. Okay. And there, look at that. It's connecting and it's downloading like 180 objects. And there you have it. I have my workspace all downloaded. So then let's say we just want to make a simple change here. So I'm just going to change this about window, and we'll just, sorry, it's a little off. This is still a little too big here. Let me squish it down for you. Okay, here we go. And where are we here? We're in the about. Okay, well, let's just change the title to About Elevate 2019. How about that? Okay, excellent changes. I save this, and then this is where you can see that green check mark that is checked out, but it's not really checked out. It just means we modified it. And one thing we can do is we can do a git diff, and well, I'm again having the problem where we're not seeing everything here, but yeah, so you can see the change I just made. That's very cool. Okay, and then so we want to check this in. You can check it in at the object level or at the pibble level. I mean, you can check in. You can give a git commit at the pibble level, the object level, or at the pibble level, or at the target level, or at the workspace level. So I don't know. We'll just do it at the pibble level for kicks and giggles, and it'll, you know, if there could be multiple objects changed here, and you can unselect the ones, but the idea is you want to commit them in a set of related changes. I don't know. We'll say update the name. The name, whatever. And then so that committed it to the local repository, and then you notice here there's no push here, so we want to do the push here at the workspace. Get push. There you go. Now hopefully we're paused, and if not, it's going to be crazy makings. Oh, I'm just going to unpause it. Hopefully we're recording now. I don't know where you can see that. Okay. Fine. So I'm flipping over to a different machine here. And so it looks like we're recording. Very nice. So here we are. And here we are. You can see the repo. And you can see the change we just made here. Update name. And then over here, well, we kind of missed it, but it just did a rebuild of updated the name. And if you click here, it'll show us the log of what happened. So it detected a change. It initialized the job, and then it did a get. Well, what's the main thing we did? I guess we do. I don't know. We're getting all from our repo, which is called fresh demo. Okay, and then I run a couple PowerShell scripts here. This is all defined in the YAML for the project, and we'll look at that in a second here. And then this is just another PowerShell script where I'm just checking out the value of these variables. This is where it gets the source to agent underscore work 1s, and then this is the build script name. So then this one's the build script, which calls the Orca script, which calls so right here we're doing the Orca script, and then it calls the PBC 190 script down here, and anyway, there you go. So that's the whole job. So it's perfect. Here ends the demo. Oh, I was going to show you the YAML. Just a second. So if we go back here to Fresh Demo, to Pipelines. Oh, no, under Fresh Demo, sorry. Right here, you click on Edit, and that takes you to the YAML file that defines the build. So we have here changes to the master, triggers the build. I think we saw all this before. A couple, and then couple PowerScript shell commands and the batch command, and some stuff that's commented out with the hash. The hash is what you use to comment out a line here. So there you go. I think that is everything. One other thing that's kind of cool. Well, I think we kind of looked at that already. Okay, here ends the demo. Thanks. Okay, we are. I have a question for everybody. What are some build-related problems you've encountered? Well, one thing is that your build might be very manual, and every time you do it, or every other time you do it, you make a mistake. So then people are trying to test stuff or run stuff in production and it's broken. Another problem might be that you don't build from your repository. So you might have something that you just kind of lost track of, or you overwrote a change, or so you have a regression defect, or what other problems might you have? I don't know. Maybe there's no way to audit things. Like you make changes and they go into a build and people are like, well, it broke. What'd you change? And you're like, well, I'm not sure what I changed. I think I changed this and this, but you know, it's possible that you made another change, you forgot about it, and then you broke your build and you don't know why. Anyway, some things that might happen. Can an Azure DevOps pipelines help resolve these issues? And I would say they can help all those issues. They can help with your audit trail. They can help ensure that you're building from a known source. If you break things, you'll know about it right away. I think being timely about so many things in software development can help you be more effective, because it's, you know, you did a push, it broke the build, you were just working on it, so you know exactly what it was that you messed up. You don't have to like get your mind back into that mode. And then hopefully you can test it and deploy it quickly as well, so that the users remember exactly what it was they asked for, and if there's a problem in production, it's still fresh in your mind, so you can fix it, and then you can start with another issue. So, do you have any questions for me? Young man down there in the front row, yeah, what's your question? Yes, I am open to consulting opportunities, even though I work for the city. The city does allow me to have other gigs. So I'm open to that possibility. If you want to contact me directly, though, I would recommend sending me an email at hanner, HANNER, @gmail.com. So that wraps up this presentation. Thanks for coming. And if you have any questions, other questions, personal questions, whatever, feel free to come up and grab me, or I can catch you later in another session. And I'll be here at the conference all week, and I'm sure I'll see you around. Thank you.